learned that all elements of an array must be of the same type. Such arrays are said to be homogeneous. Well, what if we want to group together heterogeneous data somehow? That is, data of multiple types. Well, MATLAB, like many other languages, provides ways to do that. The easiest way is to use a struct. A struct is different from an array in three ways. 1. Structs have fields, not elements. 2. We access the fields of a struct by names, not indices. And 3. Fields within the same struct can have different types. What's especially cool is that the field of a struct can be another struct, and that ability of a struct to have another struct inside it makes structs very versatile. The syntax for creating or accessing the field of a struct relies on the period, or dot. If we type r dot ssn equals 1, 2, 3, 4, 5, 6, 7, 8, MATLAB will create a new variable named r, make it a struct, create a field called SSN for that struct, and assign it the value 12,345,678. So the syntax is simply to put a dot between the variable name and the name of the field. Easy. Now if we check the data type of the variable r with the class function, we get struct as expected. But if we check the data type of the SSN field, we get double, which is also what we should expect since we assigned a number to that field. Okay, so we've created a brand new struct. Now we can add a new field to that struct simply by typing r.name equals, quote, Homer Simpson, end quote. MATLAB will modify our struct by adding a new field called name, and it will assign the string Homer Simpson as the value of that field. Now here comes the cool part I mentioned. Typing r.address.street equals single quote 742 Evergreen Terrace single quote creates another field for r called address. And because of the dot after address, this new field is itself a struct with its own field, which is called street. And then it assigns the string 742 Evergreen Terrace to the field street of the field address of the variable r. As you can see, MATLAB doesn't print the inside of this new struct in the command window directly. Instead, it just signals that the field address of the struct r is another struct. As I said, allowing a field to be a struct makes structs really versatile. But there's more versatility here than that, because structs can hold arrays, and arrays can hold structs. In other words, a field of a struct can be an array, and it goes the other way too. An element of an array can be a struct. But in that direction, we encounter the homogeneity rule. All array elements must be of the same type. So if they're structs, they must all have the same fields. We'll see some examples shortly, but first, you'll not be surprised when I tell you that MATLAB has some useful built-in functions that deal with structs. For example, isField will tell you whether a struct has a certain field. You just give it the struct and the name of the field you're looking for, and it'll return true or false. And setField can add new fields to a struct in a dynamic manner, meaning that you don't have to know the name of the field when you're writing your program. The user can specify it while your program is running, for example. Another handy function is called RMField, which means remove field. It can produce a struct that's a duplicate of another struct, except that a specified field is missing. You give it the struct and the name of the field you want to remove, and it returns a copy with that field removed. Finally, if you want to create a struct with a set of names in one shot, you can simply call the function nameStruct and give it the field names you want as arguments. Okay, we've learned about structs, and now we're ready to see them working in MATLAB. Information about a bank account is pretty heterogeneous. An account has an owner, which is probably going to be a string, an account number, which will be a number, and a balance, which will be a number, etc. Let's create a struct that represents a bank account. The value that we've assigned to the variable account here is a struct. Class will tell us that. And its first two fields are doubles. This third field is a struct, as we can see right here, called owner. And owner has a couple of fields, which we can look at by typing the variable name, dot, and the name of the field, owner, to see what's inside it. And it has two fields. When we see these two fields with this colon here, we know that we're looking at a struct. And they happen to be both of the same type. As we can see, these quotes are included by MATLAB when it gives the value of a struct field that happens to be a char. If we want to turn a count into an array of structs, it's easy enough to do. We just give it another element. And we did that by assigning something to one of its fields. As you can see, MATLAB prints out only the field names once we have a struct array. Also, the new struct, well, the second element of the array, magically has all the same fields that the first element already had, not just the account number we created. This has to happen to keep the types of both elements the same. Remember that homogeneous rule? If some elements had one set of fields and others had another set, well, homogeneity would be out the window. So what values are in these fields that showed up automatically? Well, let's just have a look. Well, they're initialized to the empty array. Let's assign values to more fields of our new struct. If we want to see the entire struct, we can do this. But if we want to see the value of a field of a substruct, we have to type in the entire hierarchical name. The array name, the index in parentheses, the dot, the field name, another dot, and the field name of the substruct. Well, let me just do one. And I'll do the other one. While the structs must have the same field names, the values stored in those fields don't have to match. They can have different types and or different sizes. For example, the length of the strings in owner dot names are different for elements 1 and 2. Let's prove that. One's 9, one's 11. And substructs don't even have to have the same set of fields. Here we've added a substruct to owner, given it the value 23 for element 1. So what about element 2? Does a new field called age show up under its owner with maybe a empty matrix or something in it? No. Reference to non-existent field age. It doesn't even have that field. The homogeneity rule for arrays is only skin deep. It extends only to the first level of the fields. Every element of the array account has to have the fields number, balance, and owner, but different things can be inside them. Okay, that's a look at how fields of structs are accessed and the homogeneity rule for an array of structs. Now let's try some of the functions that work with structs, some that we've mentioned before. First, let's clear this cluttered screen and look at the owner field of each element of account. Putting that 1:2 in there makes it show each one of these elements. And we see there's quite a few things in 1 and not much in 2. Well, let's look at is field. So what we see here is the is field takes this argument, which is account 2, the second one, dot owner. It looks at the field of account 2 called owner and checks to see if there's a field in there called age. Well, there's not, so it returns false or 0. And we do the same thing with element 1. Well, if we go inside owner for element 1, we find there is a field called age. And so we get true. As we said, is field returns true or false, depending on whether the given structure has a field with the given name. And then there's RM field, which you may remember removes a field from a struct. Let's remove age from account1.owner. There, age field is gone along with its value, which was 23. You give the thing you want to remove the field from, then you give the name of the field that you want to remove. Now let's just check to make sure that it's gone. Wait, why is age still there? We just removed it. Well, we've made one of those rookie errors. The function RM field doesn't change its argument. This was its argument, account1.owner. That's not the way MATLAB works. It returns a changed version of its argument. That's what we saw here. So when we checked out the argument that we gave it, it's unchanged. It's still the same. If we want to change it, we have to assign something to it. That's easy to do. We do it like this. First of all, I'll click my up arrow and get that command back. And over here, I type account1.owner, and the result from RM field will be assigned back to it. So let's hit return and see what happens. Now let's check. Age is gone. Okay, we got one last function that works on structs to look at, and its name is struct. You remember when we started all these struct examples, we needed to have some structs to work with, and you do that by giving a variable some fields. We started out by giving account the field named number, and then we gave it balance and so forth. We kind of did it piecemeal, one field at a time. But you don't have to do it that way. You can do it all in one fell swoop with a built-in function whose name is struct. Like this. Man, I got my typing in high gear here. I am smoking it. Okay? Whoa. Remember, we're professionals here. We don't recommend you try typing like this at home. But anyway, the inputs to the struct function come in pairs organized as field and value. So here was the field called area. Here's the value called CS, and you can see it showed up here. Here's a field called number, and 103, which is a double, is the value for that field. Title, there you go. This method of setting values for fields by processing a list of field value, field value, field value pairs is not unique to MATLAB. It first appeared in a language called Lisp, which means list processing, shortly after Fortran was invented in the late 50s. Lisp and derivatives of it are still used today for writing programs that have artificial intelligence. We're still using this method of giving values to fields. Good ideas never die. And with that bit of programming language history, we conclude our coverage of structs.